Okay. Sir, I have run the feature extraction. Please explain again bigram, trigram. Okay. Yeah. So let me come to the again. So now, unigram, bigram, trigram. This is steps. So this is to decide what are the features that you are going to consider. Okay. Unigram means individual words. Bigram means consecutive two words. So you have to extract all possible, say, bigram. Trigram means consecutive three words. So all possible trigram you need to extract. So it is going to be really huge number of features. So you can decide whether you will or only bigram or only trigram or combination of them. You can also consider all unigram, bigram, trigram and all put together and build the vector space model. Okay. So that you have to decide. So in this program, we have just prepared for unigram. That means every tokens we have extracted. Every tokens we have extracted here. In this module, you have to prepare for bigram, if you then trigram and so on. Okay, you have to prepare. After preparing that, you have to decide what are the features. So if you say all the unigram, all the bigram, all the trigram, that means this K feature will be collection of all the unigrams, all the bigrams, all the trigrams. This is going to be really huge number of features. Okay, that's why we need to do feature selection, because all of these features are not going to be important. So us how to define feature importance, that is what we're going to do in the feature selection, because many of these features are not useful, so we have to throw away those useless features. Okay. So then even after identifying these use, you may end up to something like 500 features. Okay, so you have considered all the useful features, still you are having 500 features. So uh, so can I further reduce from 500 to 10 features or 100 features? Okay, that is the dimension reduction. So another question is, will you take a demo for medical image processing? Like uh, for the image processing domain is a bit different. Okay, but for some generic application, like say if you have a collection of images, because okay, this is a very, let us spend some time how to do image processing in very root manner. So let us say I have, instead of text, I have image. Okay, I don't want to do any pre-processing on the image. Whatever image that I have, I want to directly use and perform some classification task. Okay. So then what happens is the image, let us say images of something like 1000 by 1000 resolution and RGB image. Okay. Then this given image is a sample. So as I said, our first task is to convert this image into a vector space model. How do I convert this into vector space model? Okay, so one simple way of converting is in the image also. If you have 1000 by 1000 resolution, that means what you have. You have it is a matrix of 1000 rows and 1000 columns, right? If it is the gray image, black and white. If it is RGB, you have this kind of 1000 by 1000 three plates, right? So one way of converting rows you extract and concatenate them. 1000 by 1000 resolution image is converted to a vector of 1000 into 1000. So if this matrix, I just concatenate them and make a vector. Okay. So this is one way of converting this one. Okay. So this is the very root way of processing image that you can apply to any of these models. but this kind of representing your image might not be sufficient. That instead of using by these pixel positions, it may happen that you need to do some processing on the image and capture some specialized features, like say you identify in the image and find the position of the edges and so on. So that is the image processing domain where I don't have the expertise. And I think this in this program we will be focusing on the text part, but hopefully in the subsequent programs, if we have, we will try to extend to others. Okay, but for image, you can use those images using by representing that root manners. Okay, otherwise, yeah. So we are not going to take examples. Another question is, sir, in social media, will have text, audio, video as well. So how to convert this efficiently to a model? Uh, okay. Of combining them, okay. This is something like multi. Uh, Dr. Sardi has discussed in the morning. Okay. So in some of our lab, what we do is we are not considering image and the videos at this point, but we are considering relations, text and a graph. In social media, you have content and relations, right? You have text and relations. So there are some models, something like multitasking, can say consider multiple of the same thing. Okay. So, like multitasking problem or say multimodal problem, they can integrate heterogeneous information together and say perform the say target task. For us, we are integrating text data, joining them together, and performing say sentiment analysis, and then like say identifying the communine and the non-communine and so on. Okay, so just to summarize, in terms of model, there are models that can consider multiple heterogeneous inputs and they combine them together. Okay. So this combination, in one way of combining the traditional classifier is you build a classifier using only the text, you build a classifier using only the image, and you build some ensembling classifier. Ensembling means you combine multiple classifiers and try to build a single classifier by combining multiple classifiers, which is called ensembling. Okay. So traditional classifier you can build using uni models and ensemble them. This you can inside the learning model itself you can combine them. Okay, like multi models and so on. So that there are models. Okay, one models is what we see in the morning. You can also refer to something like multitasking. Okay? So you can perform multiple tasks and combine them together. Okay, that is also you can perform. Okay, one question is uh, based analysis of social media with huge data is a Herculean task. What kind of computer infrastructure? Okay, what kind of computer infrastructure is required to perform this? Okay, this answer is very tricky. So I have also seen some query from the participants in the similar questions. So on the last day, I am planning a session to explain the infrastructure and the modules and say different database and learning platform that we have set up in our lab for performing high-end processing in the streaming data, network data, and so on. Okay, with respect to the tool yesterday. So that is nothing but the Bislesaki. Okay, let me just try to show SINT ITC. So if you go to lab website, this is our lab website. So since lockdown, I think contents are not updated, but still majority of activities you can see here. Yeah, so this is the tool that we are building. This is kind of monitoring data sets. So we every day we collect about 10 to 15 lakhs of tweets and index them, analyze them, and so on. The underlying, say, modules, infrastructure of such system. What are the database that we are using? That on the last day, I'm planning to have one session on that, and this will probably answer these questions. Please wait till the last day. On last day, we'll have. So, any other questions? Any question that I have not answered? So, so if we do not have, difference between confusion matrix and AUC, convolution matrix. Convolution matrix. I'm not convolution matrix. I am not very clear. But do you mean the confusion? Okay, AUC I can explain, but AUC is something like this. You first try to visualize false positive rate and recall false negative rate. So you try to when for you try to visualize a classifier with different setups, like some different experimental setups or thresholds. So for one setup, you are going to get one say false positive rate and a false negative rate. That is one point in this say in this ROC curve. So likewise, you try to change different setups and try to get different ROC points. Okay, so if you try to connect these points, you will get the ROC curve. So area under this curve is the AUC curve, AUC score. Okay, that is this one. So please mention some of the open research problem. So this, because we have just started the session and we just started the basic framework. So this open question, shall we leave this to say 4th day and a 5th day, 5th day? So we'll because there we are having some specialized topics that will throw these open issues. So let us have say some special discussion on the 4th or 5th day, 5th day. Okay. Confusion matrix. So I think it was confusion matrix. Confusion matrix contains true positive, true negative, false, and so on, from which you can estimate sensitivity and specificity to draw the ROC curve. ROC curve, yeah, this is correct. So I think one of you participant also has answered these questions. Okay, so please, yeah, this. Thank you, Sachi. Let me share this comment from participant to all. Okay, usually how is annotation done? So this is a very difficult task. So the way we do our annotation in the lab is we give to the annotator and we give instruction to the annotator how to do annotation depending on the problem. For example, for a sentiment analysis, we employ two people to annotate and we give the instructions. So this annotator will give class levels and we take the agreement. So larger the number of annotators, I think better is going to be the quality of the data sets. But so we have to engage annotators, take the majority decisions. But how to engage nowadays, like Amazon Trunk and so on, they do crowdsource to many peoples and then collect the data. Okay, so we have to engage annotator. Okay, query regarding annotators. Do you calculate kappa coefficient? Yeah, so the data set that we have used is not our data sets, but calculating kappa coefficient is important. So for our data set, we calculate kappa coefficient. It gets about 83. Is it about 83?
Yeah, 83 point something. 83, around about 83.
The calculating kappa coefficient is, I think, it is important. So thank you very much. So I think from today's session, the point that I have marked is one question is how to select important features and the dimension reductions and the confusion between these two. So let us pick up these two tomorrow. Then if we have time, maybe we'll also try to show the classifier that we have seen today is are all these are all backward framework. What means the vector space framework. It is not sequential in nature. So NER or part of speech trigger that Dr. Ashish discussed in the previous session, that those are a sequential problem. So if time permit, we also try to see some of the sequential models after, say, discussing the feature importance and the dimension reductions. So with this, thank you very much for your patience, and yeah, hope you have you could learn at least some basic stuff from this lecture. Thank you very much. Okay, one question I think, can you please talk on micro and a macro? Okay, micro and a macro average. This is okay. This is for finding average. Uh, let us say something. Okay. Let us say in one experimental setup, you have got some performance at precision equal to zero point 0.7, for example. In another experimental setup, if you say you have got something like precision zero point 0.9, okay. If you try to take average on this without worrying, how do you actually get the precision? Okay, the precision that you're getting, you're just taking average. That is the macro. If you want to do micro, then instead of taking the final precision, you combine the say confusion matrix of the first setup, confusion matrix of the second setup, combine them and try to estimate the precision. Okay, that is the micro. Do I answer your question? So if you try to average the final precision, then it is the macro, and instead you merge the confusion matrix of first setup and second setup, then this is the micro. Okay, so hope you could get something out of this session, and tomorrow we'll see the say physical engineering, some discussion on the physical engineering. Thank you very much.
Thank you. Sure.
Thank you, sir.
Thank you, sir. It was a nice session.
Tomorrow, what time we'll start?
Okay, just tomorrow we have 2 sessions in the morning. The first session is the industry talk, and the second session is the recommendation problems in social media analytics. Yeah, that is
First session is
and
first session
Kent.
industry. Who will talk? Anything?
Says from Sec Lab, he will be talking. So Sec Lab is one security company, and they are developing many tools,
Including social media analytics.
including security in social media. So yeah, Mr. Sess will talk about it on the Sec Lab.
Fine. And this today's tutorial will be is available in GitHub, correct?
This dataset and the programs are available. They can download and use it.
Okay, fine. Okay.
Thank you very much.
See you.
Thank you, sir. Yeah, dear participants, we will send the link today evening. Thank you very much for tomorrow's evening.